Hi, this is Mrs. LaBarbara. Today I'm going to talk about scientific notation and SI prefixes. The objective for today is to know the form of scientific notation, to know the SI prefixes, to be able to perform mathematical operations on numbers with scientific able to convert between SI prefixes, to be able to perform order of magnitude calculations. First, scientific notation is used to represent a very large and a very small numbers. For example, the mass of the Earth is 598 followed by 22 zeros kilograms. As you can see, it is very inconvenient to write such a big number. So an easier way to write such a big number is to use scientific notation. The general form for scientific notation is a times 10 to the n. In this number, a is greater or equals to 1 and less than 10. N is an integer. It could be positive or negative. For example, the mass of the Earth is 598 followed by 22 zeros, can be written as 5.98 times 10 to the 24. So it's a lot easier than to write 598 followed by 22 zeros. The other example of scientific notation are 5.1 times 10 to the negative 2 or 2 times 10 to the 5. Let's do some practices. First, this number, 6,370,000 meters, can be expressed in scientific notation as the first number has to be greater or equals to 1 less than 10. So the first number becomes 6.37. Since your decimal point is here, change it to here. So your power becomes positive. When you move the decimal point 6 times to the left, that's where your power becomes positive 6. Another example, 0.0000000000667 can be expressed as the first number should be 6.67, multiply 10 to the power of something. Now, since you moved the decimal point from here all the way to the right, over here, moved it 11 times to the right, so your power should be negative 11. Another example, you move the decimal point to the right 3 times because the first number should be 4. So your order of the power should be negative 3. 4 times 10 to the negative 3. The opposite of writing a number into scientific notation is to expand a number in scientific notation as a regular number. To expand it, if its power is negative, you need to move the decimal point to the left 3 times. If the power is positive, you move the decimal point to the right 7 times. So that's what you should have. Now, how do we perform mathematical operations on numbers with scientific notation or EE notation? For example, 3 million, 3 followed by 6 zeros. So in the calculator, you can write down 3 times 10 to the power of 6, or you can write 3e6. So 3e6, this is a much easier way because we don't need to put parentheses when we do calculations. I want to remind everybody this is not 3 times 10 e6, it's just 3e6. So somebody probably, or some of you probably know what it means. For those of you who does not know what it means, take out your calculator. If you have a graphing calculator, this is the button is EE. So you need to second EE. To write this number, you use 3, second EE 6. Now, if you don't have a graphing calculator, you have a scientific calculator. It's very similar. 3, second EE 6. That's how you write the number. An example, perform this operation. 2 times 10 to the 2 divided by 4 times 10 to the negative 4. So if you do the regular way, you must put parentheses as 10 to the power of 2 divided by parentheses 4 times 10 to the power of negative 4. If you use the second EE button, you don't need parentheses. Either way, you should have the same answer, 5 followed by 5 zeros, or if you write this number in scientific notation, you should have 5.0 times 10 to the 5, or on the calculator, maybe becomes 5e to the 5. Remember, when you write this, the answer should be 5.0 times 10 to the 5 because that is the two significant figures. So when performing calculations with scientific notation, the rules for significant figure applies. Since you have 2 sig figs here, you have 2 sig figs here, the result should be 2 sig figs. Now I want you to type this number in the calculator and see what you have. Remember, we prefer to use second EE button. This way you don't have to use parentheses. So after you perform this, you should have this number, 1.99 times 10 to the 20. Next one, I want to talk about order of magnitude. So order of magnitude is a scale to measure how large or how small a number is. It is used to make approximate comparison. So order of magnitude is based on power of 10. What does that mean? For example, an average man's height is 1.75 meters. So basically, we want to compare how this number, is this number close to 1 or is this close to 10? So obviously, you know, well, I know this number is close to 1. But sometimes it's not so obvious. In this case, 1.75 is the same as 1.75 times 10 to the 0 meters. You see this is 10 to the 0, this is 1. So the power over here, this indicates order of magnitude. So we say this number, 1.75, has an order of magnitude of 0. Another example. Average car's mass is 1,000 kilograms. To write this in scientific notation, this number becomes 1.0 times 10 to the 3 kilograms. Again, the power is 3, so we say 1,000 has an order of magnitude of 3. Another example. The average distance between the Earth and the Moon is 3.84 times 10 to the 8th meters. So here is a number with 10 to the 8. The power is 8. So we say the order of magnitude of this distance is 8. An example, what is the order of the magnitude of the ratio of electrostatic constant to the universal gravitational constant? So all the constants are listed on your reference table on the first page. Ratio means to divide. So look at your reference table. Electrostatic constant is 8.99 times 10 to the 9. Universal gravitational constant is 6.67 times 10 to the negative 11. You can put this in the calculator using second EE button. You should have 1.34 times 10 to the 20. Now the order of magnitude is 20 because that's the power. Next one is SI prefix. So SI prefixes are prefixes, which are these symbols, combined with SI units. What are the SI units? That's meters, grams, and seconds, to form a new unit that is much larger or much smaller than the base unit. The symbols for the new unit consists of the symbol for the prefix followed by the symbol of the base unit. For example, 2 terameters, the prefix and the base unit. And that equals to 2 times 10 to the 12 meters. Where did we get 10 to the 12? Look at your scientific notation corresponding to T. That's where it comes from. So this means 2 terameter is 10 to the 12 times larger than 2 meter. Now that's a practice, 7 nanometers. How many meters is that? 7 nano. Look at the nano is 10 to the negative 9. So this is 7 times 10 to the negative 9 meter. 6 micrometer would be 6 times 10 to the negative 6 meter. How do we convert? Let's see. Convert is kind of like algebra. 1 megameter equals how many kilometers? We can change this into the math. 1 megameters equals x kilometers, which means really x times 1 kilometers. How do you solve for x? You divide. So to convert is to divide. X equals to 1 megagrams divided by 1 kilograms. What is the prefix for mega? 10 to the 6 grams. Prefix for kilo, 3. So 10 to the 3, you divide. You can do this on a calculator, or remember to divide. The scientific notation is to subtract the exponents. Another example. 7,191 meters equals to how many kilometers? Now this one has no prefix. No prefix is right over here. That means it's 10 to the 0. 10 to the 0 is 1, so you don't really have to do anything with this number, right? So to find x, you divide. So this number has no prefix, so just leave it alone. K is 10 to the 3, so that's what you have. So 7,191 meters equals 7.191 kilometers. Another example. 6,398 times 10 to the negative 2 megameters equals to how many meters? So here is 10 to the negative 2, leave it alone. This is just number in front of prefix. So again, you divide. This has no prefix, that means it's 1. So mega means 10 to the 6. So this is the result you have. And to express this number in scientific notation, it becomes 6.398 times 10 to the 7 meters. So that's what you have. And here is again, to convert is to divide. So divide exponents, and your answer should be this. Last one, to convert is to divide. That's what you should have in scientific notation. And I hope that helps. See you next time.